Question 7. An object of mass 0.5 kilograms is thrown vertically upwards with initial speed 24 meters per second. The velocity of the object at time t is v. During the upward motion, the object experiences a resistance to motion r, where r is proportional to v. When the velocity of the object is 0.2, the resistance to motion is 0.08. Part A, show that the upward motion satisfies this equation. Okay, this is not quite so obvious as some could be on this topic. Let's draw a little picture. So we're moving upwards. Okay, just imagine it's a ball being thrown upwards. We've got 0.5 g trying to pull it back down, its weight, ma, and we've also got a resistance to motion, r. So when we say F equals ma in the direction of motion, which is upwards, we've got a pair of forces that are trying to slow it down. We don't have a forwards force. If you want to put 0 minus 0.5 g and minus r, you can put 0 in for now, okay? Or you can just not put anything as a forward force. That's fine. That then will equal 0.5 a. But the equation we're trying to get to doesn't have r, and we haven't used this proportional bit of information. Okay, so let's try and think about what that would be. If r is proportional to v, it means it's a multiple of. Okay, that's what this idea of proportionality means. If it's always double it, or always half of it, or always a million times it, that's the proportional idea. So we can say that r is equal to kv, where k is just a number. Okay, we'll sometimes see this happen in the pure differential equations, and sometimes we see it happen in the mechanics differential equations. So we could just put it in as kv, but notice there isn't even a k here. And that's because they've given us a bit of information that we can use immediately to work out k. It doesn't hang around as a k like lots of other questions we've seen that happen in. Okay, so if we sub in when v is 0.2, r is 0.08, we get 0.08 is k times 0.2. Therefore, if you divide 0.08 by 0.2, you will get 2/5 or 0.4. So we know that this resistance force is 0.4 v. So we're going to put that over here and say, okay, it's minus 0.5 g minus 0.4 v is equal to 0.5. And remember, we can change acceleration into dv by dt, because that's the rate of change of velocity compared to time. And then it looks like we've just divided through by 0.5, because we've lost the 0.5 in front of the dv by dt. So either imagine dividing by 0.5, or on the other hand, timesing by 2. Okay, so negative 0.5 times 9.8, but then divided by 0.5, and you get back to the minus 9.8, which is what we wanted here. If you've got negative 0.4 divided by 0.5, that's where we get the negative 0.8. And then we've lost the 0.5 on that side. So there's our differential equation, and we've got to that line.